Hello learners, we continue this session again with discounted cash flow techniques. In the previous session, you learnt about NPV method and profitability index method. In this session, we will learn about internal rate of return. Now, sometimes when you read the examination question, all the parameters are given, that is cash outflow, cash inflow, regular cash inflow, terminal cash inflow, everything is given, but discount rate for calculating present value is not given, and you are required to calculate internal rate of return, that is IRR. Now, what IRR is? IRR means such discount rate at which NPV of the project becomes 0. For example, if a project is there in which we make an investment of 50 crore rupees, project has a life of 7 years, it will have mixed bag of inflow, and by applying the method of calculating IRR, if our answer for IRR is 16%, 16%, this simply implies that by using 16% discount rate, NPV of the project is 0, number 1, and as explained earlier, 0 NPV means if you make an investment in that project, your return will be equal to the discount rate used for calculating present value. So, by investing in that project, our year on year return will be 16% on the time scale, that is up till 7 years. So, that is the meaning of IRR. So, IRR means such discount rate at which project related NPV is 0, and if we invest in that project, the return will be equal to the discount rate used for calculating present value. So, that is the meaning of IRR. Let us proceed further how it is calculated. So, the IRR is defined as such discount rate which equates the sum total of present value of operating cash flow and terminal cash flow. As you can see, we will be calculating PV of all the cash inflows, operating cash inflow, that is also known as regular cash inflow or CFAT, and terminal cash inflow. Terminal cash inflow comprises of salvage value or the scrap value realized by selling the project or second hand assets or used assets, as well as recovery of working capital. And so, present value of all the cash inflow becomes equal to the present value of cash outflow, that means NPV is 0, and I have explained you few minutes ago what is the role of IRR. Now, question comes, what is the rule for accepting or rejecting a project, for accepting or not accepting a project? Every businessman assigns a cut-off rate. Now, by cut-off rate I mean minimum required rate of return. How much minimum return are expected while making an investment? If suppose you are a finance executive and your guidelines say that you will accept all those projects subject to the availability of funds, you will accept all those projects for which minimum return is 20%. Then all the projects for which IRR is equal to 20% or more than 20%, you will accept, else projects will be rejected. So, IRR helps us in taking a decision. So, the project will be accepted when IRR exceeds the required rate of return. So, it means if IRR is equal to or greater than the cut-off rate, you can say cut-off rate, minimum required rate of return, or hurdle rate, or cost of capital will be accepted, else they will be rejected. So, internal rate of return symbolically can be calculated like this. That means formula is the same as we applied in NPV. Only thing is that this R we have to find out. This R we have to find out. So, this R has to be worked out. and that is the definition of IRR also, simple and one line definition. such discount rate at which NPV of the project becomes 0. Now, how do we find out IRR? Now, if you remember, for any kind of capital budgeting project or investment appraisal project, two kind of scenario might be there with reference to the pattern of inflow. Either inflow may be in the form of an annuity, that means every year same amount of CF80 is generated, or inflow may be uneven, that means in one year it is some different value, in second year it is some different value, or in all the years same value is not there, at least one of the years has the different value. So, two scenario might be there. So, first I will be taking a scenario in which cash inflow is in the shape of an annuity. An annuity means every period we get the same amount at a regular interval for a definite time period. For example, every year you will get 11,200 for 5 years. Definitely it becomes an annuity of 11,200 running for 5 years. So, if cash inflow qualify the pattern of annuity, how to calculate IRR? Step number 1, estimate cash outflow, and definitely it will be initial cash outflow. So, my one submission or one hint at this point is that for calculating IRR, always consider initial cash outflow. Subsequent cash outflow is put as a symbol with negative, because negative flow of money means cash outflow. So, we will take that numerical also in which subsequent cash outflow is there, but that will be under the practice session. But in this session we will be taking all the numericals in which there is initial cash outflow. So, estimate initial cash outflow. Cash outflow will comprise the investment in fixed assets as well as investment in working capital. That is step number 1. Then estimate annual cash inflow, and condition number 1 in this case we are putting it has to be in the shape of an annuity. If that kind of numerical is there, follow the steps which I am going to tell you. So, you have estimated cash outflow, you have estimated annual cash inflow, that is annual CF80. Now, third number step, or we can say journey towards calculation of IRR. Calculate payback period. I hope you remember, for calculating payback period in case of an annuity, the simple formula is investment divided by annual cash inflow. You will get payback value, or we can say the target factor. You can call it as target factor also, or payback period. So, what we have calculated? Payback period. Now, what to do with this payback period? Take out the present value interest factor for an annuity table. So, table of present value of an annuity, and look for that factor in the table exactly in the row of life of the project. For example, your payback period is 3.2 years and life of the project is 10 years. So, where will you search out that 3.2 year in the present value interest time value factor or annuity factor? In the row of 10th year. Keep on moving and you will find somewhere 3.2. You might find exactly 3.2. If not, you will find some factor more than 3.2 and some factor less than 3.2. So, find out closest factor and note down the corresponding rates. So, I will now depict the complete process to arrive at approximate level of IRR. So, this is the example. A project costs 36,000 and is expected to generate cash inflow of 11,200 annually for 5 years. Calculate IRR. Now, this particular question satisfies the condition that yes, cash inflow is in the shape of an annuity. Your initial investment is 36,000, annual cash inflow is 11,200. So, payback period is simply 36,000 divided by 11,200. What answer we get? 36,000 divided by 11,200. 3.214. I have written the answer here also, and we have seen how it is calculated, 3.214. Now this 3.214 is to be located in present value annuity table exactly in the row of 5th year. If you remember how the time value table is given, on the top rate is there, on the left year is there. So exactly in the row of 5th year keep on moving, and you might find somewhere 3.214, and in many cases you will not find exactly 3.214. So your target or attempt will be finding out at least 2 factors closest to 3.214. That means one PVIFA greater than this and another PVIFA less than this, and note down those factors as well as corresponding discount rate. What you have to note down? Note down 2 closest factor, one more than the target and another less than the target. So what is your target? 3.214 equal to payback period, and note down both the factors as well as corresponding discount rates. So that we will do. Now don't pay the attention on this one, I will show you how it comes, although that is the correct one, but I have marked it, so don't go by this. I will show you the time value table also. So 3.214 we remember. This is the present value annuity table, and our target is 3.214. Our target is 3.214, which was our payback period. And what is the life of the project? 5 years. So this is present value annuity table. This is your 5th year row, n is 5. Keep on moving in this particular row, and somewhere you will find 3.214. Exactly I said you will not find, but you see the closest factors are 3.199, 3.274. That is one about 3.214, another below 3.214. So at 16% factor is 3.274, at 17% factor is 3.199. So note down both the factors and both the rates. So rate 16% is there, 17% is there. Now in this case 16% will be called as lower discount rate. 16% will be called as lower discount rate and 17% will be called as higher discount rate. This simply implies that IRR is between these two rates, but we will not leave at that point. We will find out approximate answer. That means what is the rate between 16 and 17 that will make my time value factor equal to 3.214. So note down those factors as well as the rates, and we will show you how to calculate approximate level of IRR by applying the approximation formula. So what now I am going to depict you approximation formula. Now look at the fact. What is the approximation formula for calculation of IRR? Approximation formula is simple. IRR equals to lower discount rate plus present value factor at lower discount rate minus, either you can say payback period which we calculated, or we can say target factor, This whole thing is divided by PV factor at LDR minus PV factor at HDR, and then this is multiplied with difference between HDR and LDR. HDR and LDR. Now, in our case, what was there? Lower discount rate was 16%, PV factor at 16%. I hope you remember, I will quickly work it out. 3.274, and our target was 3.214. As you remember, one factor was more than the target, that will be always at lower discount rate. Then 3.274 PV factor at lower discount rate minus the PV factor at higher discount rate, it was 3.199, and this is multiplied with higher discount rate minus lower discount rate, HDR minus LDR. So, formula becomes lower discount rate factor or time value factor at lower discount rate minus target factor, or you can say payback period, divided by present value factor at lower discount rate minus present value factor at higher discount rate, and the gap between both the discount rates. So, never forget, this gap may be more than 1 also, more than 2 also. So, always put the values and take the gap. Now, let us work it out, how much answer we get it. 16 plus 3.274 minus 3.214, we get it 0.06 divided by 0.075 times 1. So, we get it 16 plus 0.8 multiplied with 1. So, that makes it 16.8. So, our answer is 16.8%. That means to say, if we use 16.8% as discount rate to calculate present value of cash inflow, then NPV of the project will be approximately 0. So, this is approximate rate. So, we get an idea that yes, by investing 36,000 in this project, our return will be equal to 16.8% year on year. So, that is the way we have learnt about how to calculate present value of different cash flow, cash outflow, and how to arrive at IRR. IRR means such discount rate at which NPV is 0. So, always take care, calculation of IRR becomes sometimes difficult, but yes, you have to take the caution. So, we have taken one type of numerical when cash inflow is in the shape of an annuity. A recap of all the steps for calculating NPV in such case. Step number 1, estimate cash outflow, and always make it a point you have initial cash outflow. Step number 2, estimate cash inflow and identify, are these in the shape of an annuity? If yes, then this mechanism can be applied. So, for calculating IRR, first step is calculate payback period. That will become your target factor. Then this particular payback period has to be located or searched in the present value annuity table, exactly in the row of life of the project. If life is 10 years, search out that particular target factor in 10th year row. If life is 5 years, like in our case it was there, search out that way, and you will find out answer for that. As you can see, how to search for that particular one. So, let us say your payback period is 4.5 and life is 6 years. So, in the row of 6th year, keep on moving and search for 4.5 where it comes. So, you will not find 4.5 exactly. What you are finding, 4.5 falls between these two. So, note down those factors and rate corresponding to that also. Similarly, suppose, because I can show you another table also, let us say your factor is 4.05, factor is 4.05 and life is 6 years. So, this is 6 year, 4.05 will be somewhere between these two rates, 12 and 13%. So, note down both of these factors, note down both of these rates. So, this is LDR, this is HDR. This is the lower discount factor, this is higher discount factor, and then apply the approximation formula to work out approximate value of IRR. Approximation formula I had depicted, I can depict it once more also. It will be equal to lower discount rate, that is LDR, plus PV factor at LDR minus target factor. So, target factor is the payback period you have calculated divided by PV factor at LDR minus PV factor at HDR. HDR is higher discount rate multiplied with difference between both the discount rate, HDR minus LDR. By solving this, you can easily work out approximate value of IRR. Solution mechanism for this equation is simple. First of all, solve this part. Take the difference of these two, take the difference of these two, and some answer will come. Multiply that difference with this difference, and then whatever is the result, add it to this one. So, that is the way we will do it. Like in our case, it was 16 plus this gap was 0.06, this gap was 0.75, and this gap was 1. So, what we got? 16 plus 0.8 multiplied by 1. So, 0.8 multiplied by 1 will get you 0.8 plus 16. So, we got an answer 16.8%. So, that is how we calculate IRR when annuity case is there. Now, I will proceed further when case is not of an annuity, what to do. Now, at that point of time only guesswork will do, because ultimately calculation of IRR is nothing but trial and error method. If we simple take an example, what example I am going to take? Cash outflow is, that is definitely initial cash outflow is equal to, let us say 2 lakh rupees only, and life of the project is 4 years, and during these 4 years, so 1, 2, 3 and 4, so those are the years. So, life of the project is 4 years, and project will generate CF80, say 50,000, 70,000, again 70,000, and then 50,000. Calculate IRR. So, simple numerical. Now, you can see your initial investment is 2 lakh rupees, project has a life of 4 years, and cash flow after tax is 50,000, 70,000, 70,000 and 50,000. Remember these values? Now, we have to calculate IRR. Now, we can go for the guesswork. Now, where I should start with? So, hint will be there. How to get that hint? Simply, so that is the rough work we are going to do. Find out average of these. So, what average you get it? So, sum total of this is 2,40,000. So, 2,40,000 divided by 4, 60,000. So, first step to get the hint where to begin, because ultimately my purpose will be that at one discount rate present value of these should be greater than 2 lakh, and at another discount rate, present value of these should be less than 2 lakh. So, where to begin? Because rates can be any. So, average cash inflow comes out to be 60,000. Now, calculate rough factor or tentative factor or rough factor, cash outflow divided by average cash inflow. So, what we get? 3.33. So, this 3.333 has to be located in annuity table in the row of 4th year. So, we will search out for that. So, let us go to the annuity table. These values we have to remember. So, if I take you to the annuity table, so this is our annuity table. 3.3333 has to be searched in the 4th year row, and you find out 3.333 comes at this level. So, this corresponding rate we have to find out. So, let me find out the corresponding rate, what rate it becomes. So, this is 8% and this is 7%. So, we are beginning our work at 8%. We are beginning our work at 8%. So, rate will be there in the table which we will be provided. So, we are beginning with the 8%. Okay. So, that hint we get it. Now, after getting the hint, we again go to the same table which we created, year 1, 2, 3, 4. CF 80, 50,000 was in first year, 70,000 was in second year, again 70,000, and lastly 50,000. So, we get it 240. Our target is 2 lakh. So, when we use 8% discount rate to calculate the present value. So, where I am beginning? I am beginning at the first level 8%. So, calculate present value interest factor. I hope you remember how this factor is calculated. I will write down the formula for you. If you have missed it out, it is 1 upon 1 plus r raised to the power of n. So, 1 upon 1.08. So, we get it 0.926. Second comes out to be 0.857. You can look these factors in present value interest factor of rupee 1, not in the annuity, but rupee 1. First year factor, second year factor, and then we will have third year factor 0.794, and then fourth year factor 0.735, and we will get PV of cash inflow at 8%. We will get PV of cash inflow at 8%. So, 50,000 multiplied by 0.926, we get 46,300. Then 70,000 multiplied with 0.857, 59,990. Then 70,000 multiplied by 794, that is 55,580. Then 50,000 multiplied with 735.735, 36,750. Make a sum total of that. 46,300 plus 59,990 plus 55,580 plus 36,750. We get 1,98,620. It means we are just below 2 lakh. and our first attempt or second attempt, whatever it may be there, at one attempt or at one rate, sum total of present value of cash inflow should be less than the target, and at another rate it should be more than the target. So, in our first attempt using 8% as discount rate, present value of cash inflow is less than the target, target is 2 lakh. Now, remember, our next attempt should give me present value more than 2 lakh, and very near to 2 lakh we are already there. So, what we can do? We can even try the 7%, because whenever you decrease the rate, present value will shoot up, will go up. So, by how much you decrease it, it depends where we are. We are very close to 2 lakh. So, we can make second trial at 7%, and definitely our present value of cash inflow will be more than 2 lakh, which is our target. So, now what I am going to do, in the same table we can make an extension. Look for the PVIF at the rate of 7%. You can use time value table, present value of rupee 1. So, it is 1 upon 1.07. So, it is 0.935, 0.873, 0.817, 817 or 816, whatever comes according to approximation, and 0.763. Now, what we are doing? We are calculating NPV at 7%. So, 50,000 multiplied by the corresponding factor, it is 46,750. So, this is PV of cash inflow at the rate of 7%, and this was at the rate of 8%. $61,110, 57,190, then 38,150, and sum up those ones. $2,03,200. Now, you can see at 7% our PV of cash inflow is greater than target, at 8% it is less than target. Now, remember these two values, 2,03,200 and 198,620. Now, we will use the approximation formula. So, we had two rates, lower discount rate was 7%, and higher discount rate was 8%, and these are the corresponding PV of cash inflow, PV of cash inflow, and our target is cash outflow, which is 2 lakh. Now, we have to simply make an interpretation that my IRR falls between 7 and 8%, because if I use any rate between these two, definitely I will reach the target of 2 lakh and NPV will be 0. Now, we can again apply the approximation formula with little bit of the modification. What is the approximation formula for IRR? LDR plus PV of cash inflow at the rate of LDR minus, either you can say target or cash outflow. You can say target or cash outflow, hardly matters, because our target is cash outflow, initial cash outflow. Then PV of cash inflow at the rate of LDR minus PV of cash inflow at the rate of HDR. So, this formula will be used, and this will be multiplied with difference between both the rates HDR and LDR. So, similar formula we used for annuity case also, but instead of PV of cash inflow we were using factor. Now, do the approximation. Lower discount rate is 7% and PV of cash inflow at 7% is this much. Target is 2 lakh and PV of cash inflow at HDR is this much. And by chance gap between both the rates is 1% again. If gap is 2%, plug in the gap according to that and like that. So, it will be 8 minus 7. So, what we get? 7 plus difference between these two, 3200 divided by and this is multiplied with 1. So, what we get? 7 plus. So, take the answer for this first. So, it will be 3200 divided by 4580. So, that is 0.6986 multiplied with 1. So, finally, we get an answer 7.6986%. 7.6986%. That means to say, if 2 lakh is invested at 0 time in this project, internal rate of return will be 7.7% approximately. That means you will be earning a return of 7.7% on your investment per year for the life of the project, which is in this case 4 years. In this case it is 4 years. Year on year return will be 7.7%. So, by following these steps coolly, because IRR sometimes people get afraid that calculation of IRR is tough. It becomes tough only when we do the shortcuts. Always follow the steps which have been told to you. Calculate initial cash outflow, estimate cash inflow, either it will be in the shape of an annuity, then apply the process of calculating IRR as explained for annuity, or it may not be in the form of an annuity, then apply the process as explained and carefully apply the formula and carefully solve it out. Definitely your answer will be correct. So, that is the way IRR is calculated. So, dear learners, we have completed all the methods of capital budgeting. We started with basic concept, we started with calculation of operating cash inflow, calculation of terminal cash inflow, calculation of cash outflow, and we applied all the methods, non-discounted cash flow methods, that is payback period method and ARR method. We learnt about discounted cash flow methods, that is NPV method, profitability index method, also known as benefit cost ratio method, and lastly we have learnt about IRR, that is internal rate of return. So, these are the 5 prominent and basic methods are used under capital budgeting techniques or capital budgeting methods for evaluating projects from financial feasibility viewpoint. Now, in the next video, we will practice all the 5 methods. So, what we can do? We can pick up 1 or 2 numericals, practice extensively on all the 5 methods, so that we are handy and perfect in all the methods. Till then, keep on revising, keep on learning. Thank you, wish you good luck.